Hello viewer, welcome to our chemistry lesson. Today we are going to be in topic lesson number 3 in electrochemistry. Your presenter is none other than Hilary Ifuske, a teacher of chemistry, and I love to continue learning even amidst this pandemic. Basically, today we are going to peel on the concept that we learned on the previous lesson. In the previous lesson, we were actually learning on the rules as applied in assigning the oxidation number. And today, we are going to actually look further in electrochemistry. But today, it is actually a new concept, but it is integrating the concepts that you have learned before. And today we are going to look at the, what you call displacement reaction. Hope you understand the word displacement. Displacement means you get take something from here, then you displace, you remove that a new position. That is actually what you call displacement. And now reaction, that means a reaction which involves removing another substance from maybe ions or actually a solution. So basically, that is exactly what we're going to be learning today. So our objectives of this lesson are as follows. The learner should be able to achieve the following. That is actually explain the change of oxidation numbers during redox or displacement reaction. Explain the change of oxidation numbers during redox or displacement reaction. The terms here are not new, especially redox. Redox means reduction, oxidation. Reduction, oxidation taking place at the same time. So that basically means that we'll be having a reaction which involves oxidation and reduction taking place simultaneously. And therefore, in an equation, you should be able to deduce which one is being oxidized, which one is being reduced, and which one is an oxidizing species, which one is a reducing species. Now, let's look at another thing. Then arrange the element in order of their reducing power. Arrange the elements in order of reducing power. That's like another objective that you are going to should be able to actually get at the end of this lesson. Now, let's look at this. Now, using the concept of oxidation numbers as increasing and decreasing in oxidation numbers, the oxidizing and reducing species or reducing agent, let us use this word, reducing agent, can be determined as in the following examples. Now, this is an example which is actually going to make you to understand more about this. And I'm going to dwell more about this example so that for you to understand this. Now, I hope by now, when you are told to actually give the oxidation number of copper here, in the copper ions here, you should be able to give as who I have given here. That now the oxidation number of this is positive 2. Now, this is an atom. An atom here has oxidation number of 0. Why? Because earlier on we have seen this. So it is now obvious. This one is positive 2, this one is 0. Now, when a chemical reaction takes place, this one is a less reactive method. This one is a more reactive method. This one is in a solution. And therefore, it is actually done what? It is displaced. That means it is gaining the electrons. This one is losing the electrons. The electrons are gained by what? By copper. So therefore, this one increase in oxidation number. So we have 0 to positive 2. Is that an increase or a decrease? Obviously, it's a decrease because from 0 you move to the right hand side, and everything that you are moving to the right hand side is actually an increment. It's an increment. You move to the right hand side on actually in mathematics we have a division of positive, negative, and positive, and we have a 0 in between. Now, so we have that. So we have 0 to positive 2. Copper here is actually moving from from positive 2 to 0. That is actually a reduction. It's a reduction. This one is oxidation. This one is oxidation. This one is a reduction. Why? It is actually reducing in oxidation number. It's reducing for oxidation number. So we are saying the oxidizing species. Oxidizing species. Oxidizing species is the one which gain the electrons, and therefore copper ions here is actually the one which is gaining electrons, and therefore it's actually decreased from positive 2 to 0. This is actually what we call oxidizing species. So if you are told to identify oxidizing species, oxidizing agent here, you are going to say it is what? It is copper. Why? Because it is actually gaining the electrons to become an atom. It's gaining electrons to become an atom. Now on the other hand, a reducing agent is actually zinc. Why? Because we are saying it's actually moving from being an atom to being an ion, and therefore the oxidation number here is actually doing what? It's increasing from 0 to positive 2. It's increasing from 0 to positive 2. How we are now seeing the difference there? The one in which it undergoes a decrease in oxidation number is called an oxidizing agent. It is called an oxidizing agent. And the one which undergoes reduction. In that case, the one which is actually increasing in oxidation number is called a reducing agent. Reducing agent, why? It is actually donating the electrons, and in that process, it becomes now a reducing agent because it is going to reduce the other substance from being a more of oxidation number to being of less oxidation number. That is actually the understanding of that this concept. Now, basically, let us look at this in terms of displacement also, displacement reaction in terms of halogens. How now you know halogens? Now, we have here bromide ion and we have chlorine gas. Now, bromide ion here is in a solution, and therefore, when chlorine gas is bubbled through these bromide ions, the bromide ion will be displaced to become a liquid there, to become a liquid, and therefore, the oxidation number here is doing what? Is it increasing or decreasing? It is from -1 to 0. Now, if you put that in a number line will have here 0 and will have here -1. So it is actually going to the right hand side. That means it is actually undergoing what we call oxidation. It's undergoing oxidation. And therefore, what is this one doing? It is actually donating an electron. It's donating an electron. Now, so we are saying here, chlorine in this other end is actually reducing from 0 to -1. Why? Because it is gaining an electron. So we are saying chlorine gas, its oxidation number decreased from 0 to -1, and we have 2 moles of chloride ion. So we have that reducing agent, which is acting as actually as an oxidizing. Chlorine is an oxidizing agent, and bromide ion is a reducing agent. It's actually a reducing agent. Why? Because it is giving out the electron. Remember, this one is actually has more electrons. That's more electrons. That's why it is negative. It has more electron. More electron by 1. So when it gives out electron, it acts as a reducing agent. It acts as a reducing agent, and therefore we will have an equation like that. Maybe basically during your own free time, look at this equation whereby we have bromine gas plus zinc. We'll have zinc ion plus 2 bromide ions. So we'll have the same thing there. So whereby we have bromine gas here, which is 0. We have this one is 0. This one will give us what? It gives us +2. This one is -1. Or basically, this one is undergoing oxidation, and therefore this one is actually reducing a reducing agent. Zinc is a reducing agent. Bromine here is a what? An oxidizing agent. Why? Because it is gaining one electron. It's gaining 1 electron, and because this one is losing 2 electrons, it gains the 2 electrons here which are lost. Therefore, it's actually going to be that we have 2 bromide ions. Now, let's look at this. I think I explained that is actually oxidizing agent here is bromide, bromine liquid, and then we have reducing agent here is what? Is zinc, because it's giving out the electrons. Basically, I've handled that. Let's look at this now. Let's look at this. Now, we want to look at now the complex ions. The complex ions here. The complex ion here we have the manganate ion. Manganate 7, as you are seeing here. Ion here, the oxidation number of ion here is positive 2. And the hydrogen here is positive 1, as you have seen. Manganate here, I want you to look at this. Look at this and this. Ion here is positive 2. And this one is positive. Manganate is positive 7. When the reaction takes place, this one, the oxidation number of ion increases from positive 2 to positive 3. Increases from positive 2 to positive 3. What is the meaning of that? What is the meaning of that? And this one reduced from, manganate reduced from positive 7 to positive 2. That means that the oxidizing agent is manganate. Why? Because it is the one which is actually gaining the electrons. It is one which is gaining electrons. It gains electrons. How many electrons are gained here? Look here. This is 5 moles of ion 2 ions. That means that ion 2 is losing 5 electrons. This one will gain 5 electrons here. And when we gain 5 electrons, we will have if you add here plus 5, it gives us here positive 2 here. Why? Because 5 electrons has been added to what? To manganate ion. And therefore, it's actually reducing from 7 to 2. I hope now you are getting that. So this one actually is acting as an oxidizing agent. Manganate ion is acting as an oxidizing agent. Because it's actually reducing from positive 7 to positive 2. Now, let's look at ion 2. Ion 2 is a reducing agent, as I have said. It is actually increasing from positive 2 to positive 3. The oxidation number here is increasing from positive 2 to positive 3. It's increasing from positive 2 to positive 3. Now, I want to, during your own free time, this is the assignment for today. The assignment for today is we have 6 ions of ion 2 ions plus 14 ions of hydrogen ions plus the chromate ion like this, Cr2O7, and then 2 negative. And then we will have here 6F3, that is Fe3, that is ion 3 ion, 6 moles of ion 3 ions, and 1 mole of chromium ion, and 7 moles of water. That is the equation. So what is the question here? In the equation above, identify the oxidizing agent. Identify the oxidizing agent. So I hope you will see the one which is actually acting as oxidizing agent. And at the same time also you have to identify on the other hand the reducing agent. But I want to, if you have identified the oxidizing agent, the other one is obvious because we have 2 species here. And I want you to play between ion 2 and chromate ion. The 2 of them will give us either an oxidizing agent or a reducing agent. So that is it for today. Hope you will not forget to subscribe at the Mwalimu Sitonic to get more lessons. Subscribe that to get more lessons. Thank you very much. Thank you very much, and welcome to the next presentation. Next time, I hope you have enjoyed our presentation. And if you have more queries, you can actually ask from that channel, but we can assist you. Thank you very much. God bless you. Thank you.